Dear students, welcome to the next session of 8051 timer/counter. So today we'll discuss in detail the timer/counter modes of operation. So we have four modes in timer/counter. As in the last session I talked about TMOD register. In that we have two bits called M1 and M0. So these two bits take a four values 0001 1011. If M1 is equal to 0 and M0 is equal to 0, then we are in a timer or a counter mode 0, right? So let us discuss one by one in detail. So please listen this video lecture carefully, so that all the operations of modes are similar, only the value will be changed inside. Okay, so let us start with the mode 0. Mode 0, the name given for mode 0 is 13-bit timer slash counter mode. Timer slash counter mode, right? So in this timer slash counter mode, 13-bit timer slash counter mode. So in this 13-bit timer slash counter mode, 8 bits of THX is used. So THX is of 8-bit wide, as I said in the first lecture. THX, X can take either 0 or 1. So all the bits of THX is used, that is 8 bits, and 5 bits of TLX register is used. Out of 8 bit, only 5 bits are used here for TLX. Remaining 3 bits of TLX will be ignored. So when I add 8 bits of THX and 5 bits of TLX, total I will get a 13-bit. Total I will get a 13-bit counter or a timer. So hence the name is 13-bit timer slash counter mode. So how the diagram of this mode looks like? So this is the diagram of timer slash counter in mode 0. Okay, I may use mode 0 in terms of timer, mode 0 in terms of a counter. As I said, if in order to start this particular timer slash counter block, I need the clock pulse. I need the clock pulse. So the clock pulse, if I'm in a timer mode, the clock pulse will be generated from oscillator and 1 by 12 circuit. If I'm in a counter mode, the clock pulse will be generated with the help of pin TX, right? So I will get these pulses. So these pulses are taken into this switch, right? These pulses are taken into this switch. Then this switch will be closed, or in other words, this counter or a timer will be started only when this particular block, that is timer control block, value will be equal to 1. Okay, so how it works? The first step, I should get the value of this particular block is equal to 1. Already I talked about this block. So we here in this case we have two cases, that is if gate is equal to 0, the value of this will be equal to 1. So don't worry about this input now. When the value of this is 1, the compulsory we have to take TRX bit, that is timer run bit is equal to 1, then only I will get the value of this is equal to 1. So when the value of this whole block is equal to 1, then the switch will be closed and the timer will be started. Okay, the next case is when gate is equal to 1, the output of NOT gate will be equal to 0, and in that instant compulsory we need to take INTX bar is equal to 1. Then the output of OR gate will be equal to 1. Then output of this AND gate should be equal to 1. Then only the output of this whole block will be equal to 1. Then the switch will be closed and timer slash counter will be started. Now when I will get the 1 here, the switch will be closed. Then how it works? So since in mode 0, it is called by the name called 13-bit timer slash counter mode. Out of this 13-bit, 8 bits of THX used and 5 bits of TLX is used. Total there are 13-bit used, and the remaining 3 bits of TLX will be ignored. So when how it will start? It will start like this. For a first clock pulse, it will take 0000 H. For the next clock pulse, 0001 H. For the next clock pulse, it will take 0002 H. Similarly, what is the maximum value it can take? Since mode 0 is of 13 bit wide, the maximum value it can take is 1 F F F H. So this is the final value this mode can take. So because the value is 13 bit wide, if it is 16 bit wide, the maximum value is FF H. So since mode 0 is of 13 bit wide, the maximum value it can take is 1 FF H, 1 FF H. Okay, so when it reaches when the value of THX and TLX becomes equal to 1 FF, right, it resets, the timer / counter will resets back to 0000 H. When it resets from maximum value to the initial value, that is 0000 H, at that instant of time, the value of TFX becomes equal to 1. The value of TFX becomes equal to 1. So when it becomes equal to 1, automatically the interrupt will be generated. So when it reaches the final value, that is 1 FFH, it has to be reset to 0000 H. How to reset that value? Once again, one more clock pulse, external clock pulse is to be given in order to reset to the 0000 H. Then when the value of this particular timer or a counter resets back to 0000 H, automatically the value of TFX becomes equal to 1. And when it becomes equal to 1, the interrupt will be generated. Okay, so this is the operation of mode 0. Now let us see how a programming steps are to be written for this. The title is Steps to Program in Mode 0. Steps to Program in Mode 0. So what are the steps that we need to take? The first step we need to take is we have to load the value of TMOD register. So what does the TMOD register tells to the programmer? It tells to the programmer that which timer is to be used, whether we have to use timer 0 or a timer 1, or whether we have to use a counter 0 or a counter 1, and which mode we are using, whether we have to use 0th mode, first mode, second mode, third mode. Next, after getting the value of TMOD, we should load the initial count value. Of TLX, THX, right? This is the second step that we need to follow. Next, after loading the value of TLX and THX, we should start the timer, right? So after starting the timer, we should monitor the value of TFX. We should monitor the value of timer overflow flag, right? So whether the timer has been reached to the maximum extent and whether it is reached to the 0000 H, whether it is resets back to 0000 H. So for that we need to monitor TFX bit. When the value of TFX becomes equal to 1, we should come out of that. So keep monitoring the timer flag, see if it is raised. If a timer flag is equal to 1, then get out of it when TF becomes equal to high. Okay, so when TFX becomes equal to 1, stop the timer. We need to stop the timer, then clear TF flag for the next round. If I want to start the timer or a counter once again, we should clear the TF flag. Then go back to step 2 to load TLX and THX again. So in order to start the timer or a counter once again, we need to load the value of THX and TLX as in the case of step number 2. Load register TLX and THX with initial count values and repeat the process. So these are the steps to program in mode 0. So let us take a small example how we can write the program for these cases. For these statements we need to write the program. What is the step number 1? We have to load tmod value, right? We have to load tmod value. So this is a tmod value, right? This is the tmod value. So m0 m1 c slash t bar g, m0 m1 c slash t bar g, right? So as an example, what I'm doing here is I'm using timer 0 with mode 0. We are in mode 0 now, and I don't bother about t1, so make all the bits equal to 0 0 0 0. Then by default gate is equal to 0, we are in timer, so this bit is equal to 0, and we are in mode 0 0 0. So the total value is equal to 00h, right? So that value is to be loaded to TLX. Next, put the count value. Load the register TLX and THX with initial count value. So we should take these instructions: move TL0, I am using timer 0, right? TL0 with initial count value, THX with initial count value. I will tell you how to write these initial count value in the next further classes. Then after loading these two value, we need to write some statements. If any statements are there, we need to write the statements. Then after doing so, we have to start the timer. We have to start the timer. So how to start the timer? Timer is nothing but inserting some delay inside this particular program. So for that I am writing the instruction called a call delay. So when this instruction encounters, this particular instruction encounters a call delay, the flow will be given to delay program directly here. So in delay we have to start the program. So in delay, start the timer, right? Start the timer in sense how the starting of the timer takes place with the help of a TR bit. What does the TR bit does? It will tell whether the timer is in enabled state or a disabled state, as I said in the last class, right? When TR bit is equal to 1, then the programmer will come to know that the timer has been started or a counter has been started. So set B, in order to set a single bit, we are using set B instruction, set B space TR0, that is start the timer. So now the timer has been started. Now how the programmer will come to know that whether the timer has been reset? That is, we have to check the TF flag, right? So keep monitoring the timer overflow flag, see if it is equal to 1 or not. If it is equal to 1, then come out of that and stop the timer, right? So in order to check this particular bit, a single bit is to be checked with the help of this instruction, jump not bit. So if this bit is not equal to 1, then go give the label to the same instruction. So this instruction will be get executed until and unless TF becomes equal to 1. When TF0 will become equal to 1, it will come out of the loop. So here I have written monitor timer 0 flag until it rolls over, right? So when the value of TF becomes equal to 1, come out of it. So after coming out of it, we should stop the timer. So we should stop the timer. So how to stop the timer? Stopping the timer in sense making 0 to TR bit. So clear TR bit, stop the timer. Then after doing so, clear TF flag for next round. If I want to start the timer once again, then clear TF0, right? So after clear TF0, return instruction is to be written, so that once again it is given to the main program. Jump here. So jump here, what is the meaning of this? Jump here is nothing but we are loading the value of TL as well as TH again, so that the here is given here, right? In the second instruction, load the value TL0, TH0, and the process will be continued. So this is about mode 0, right? So this is the block diagram that we need to explain, and these are the steps to program in mode 0. We need to write these, and this is one example that how we can write the instructions for a mode 0, right? Thank you.